Hello, in this video we're going to look at some examples where the IV is running in drops per minute and we're asked to figure out, in this case, volume that is infused. So I want to take a look at what they give me, and I see on the image that the IV has been set up 25 drops per minute, and I see in reading that has been the rate for the last 8 hours. And I am also told how many drops per milliliter, so the calibration or the tubing or the drop factor. So what I want to do is I want to start with one of these pieces of information to figure out volume. Now, because this is a volume, I need to have volume end up on top. So there's lots of places to end up with volume on top, but I'm going to start with the first piece of information they gave me, which is this 25 drops per minute, which is what I would see in real life when I look at this IV pump. I would be able to, like you see in the image, use a watch or other timer and be able to count how many times this drips in the drip chamber. So 25 drops per minute with the goal of volume in milliliters. This is my goal. So the first thing that I see drops. And in the problem, they gave me a drop to milliliter conversion. So let's put that in. 15 drops is going to need to be on the bottom. 1 milliliter on top. Drops is going to cancel. And so that will get me to milliliters. And that's really good because I want milliliters. But I do have an issue because there's still minutes here. And the answer is not milliliters per minute. The answer is just in milliliters. Okay? So I know how to change milliliters into, or minutes into hours. So I know that there are 60 minutes in 1 hour. So now the labels that I have are milliliters and hours, which is great. But that's not what I'm supposed to find. I'm not supposed to find milliliters per hour. So I look at my problem. They gave me one last piece of information, 8 hours. Well, I can put that on the top. That 8 hours is not converting into anything. It is literally just canceling because the 25 drops per minute was for a total time of 8 hours. So multiplying them would give me the total amount infused. And so I can put that over 1, cancel the hours, and now the only label left is milliliters, which is the label that I want. So I'll take multiplication across the top, 25 times 60 times 8. And so that gives me 1, 2, with 3 zeros, 12,000 divided by 15. And that gives me 800 milliliters in an hour. Not in an hour, milliliters in 8 hours. Now, let's take a look at this from a different perspective. So what if I just take my rate, 25 drops per minute, and change it into milliliters per hour, because that's how I'm used to reasoning. So 1 milliliter is 15 drops. 1 minute, we'll take 60 of those to get to 1 hour. And so now I'm going to do my math. So 25 times 60 is 1,500 divided by 15. There's 2 labels left, milliliters and hours. And so that gives me 100 milliliters per hour, which is a different way of describing how fast this IV is running. But it's truly the same rate. Okay, so if I run this IV at 25 drops per minute or 100 milliliters per hour, the fluid is flowing at the same rate. Once I know the milliliter per hour rate, I can easily calculate the total volume, which is what they actually want for the answer, because I could just take that times 8 hours. And that gets me right back to this answer that we had before, 800. Let's take a look at a second example. So this time we are told I have 100 milliliters of D10W and it's infusing at 10 drops per minute, and it is set up using 15 drop per milliliter tubing. Looking at my question, it asks me how long will it take the IV to infuse? Well, if I'm going to answer a question of how long, I'm going to need time on the top, because that's going to answer the question. So looking at all the things I have, well, here I have 10 drops per minute, which gives me a time. So I'm going to say 1 minute is 10 drops. Now I'm going to need to cancel a bunch of things to get that to be time. So I'm going to use the 15 drops per milliliter, and that will cancel the drops. So using my dimensional analysis strategy, and I use this piece of information. I also have as a piece of information 100 milliliters. So I have milliliters, and I can put 100 milliliters on top, and the milliliters will cancel. That 100 milliliters was not a rate. It did not have another label with it, so I can put that at a 1. So in this case, I multiply straight across, 1500 on top divided by 10, and I find 150 minutes. Now, typically we don't tell time in minutes when it's longer than an hour, so I do have to convert this over to hours. So I'm going to do an extra conversion here, and I know that there are 60 minutes to 1 hour. Minutes cancel, and so if I take 150 divided by 60, I get 2.5. So 2.5 hours, or 2 hours, 30 minutes. Again, let's take a second look at it. How else could we do the problem? Well, another way to set up the dimensional analysis is to look at this idea, time on top, how long, time. Time is not a rate. And so since time is not a rate, I need to start with something that is not a rate. So I can start with something that is not a rate. And the one thing in the problem that is not a rate is the 100 milliliters. That is just a number, not a rate. So if I'm starting with something that is just a number, not a rate, I have only one label, and that means that I will end with something that is just a number, not a rate. So then pulling in things to cancel, I see that there are 15 drops to 1 milliliter. That will cancel milliliters. I see that this is running with 10 drops to a minute. That will cancel drops. If I did my math right now, I get the 150, but now let's go to hours. I know that there are 60 minutes to 1 hour. And that'll cancel. And if I do that math, I end up back at the 2 hours, 30 minutes, or 2.5 hours. So 2 ways to set up the dimensional analysis, 2 thought processes in that. So the one is whatever you want to solve for, make sure that's on the top. The other one is, since we want something that is not a rate, we're going to then start with something that is not a rate. And so taking those singleton numbers and doing the dimensional analysis there will also give us a good starting point that will end up working out with the right answer.